So our next example is going to be the circle. So y equals square root of 1 minus x squared. All right, that's the, if you like, that's the graph of a semicircle. And maybe we'll set it up here this way. So the semicircle goes around like this. And we'll start it here at x equals 0, and we'll go over to A. And we'll take this little piece of the circle, so down to here, if you like. All right, so here's the portion of the circle that I'm going to measure the length of. Now, we know that length, it's called arc length, and I'm going to give it a name. I'm going to call it alpha here. So alpha is the arc length along the circle. And now let's figure out what it is. First, in order to do this, I have to figure out what y prime is, or if you like, dy dx. Now, that's a calculation that we've done a number of times, and I'm going to do it slightly faster. But you remember, it gives you a square root in the denominator, and then you have the derivative of what's inside the square root, which is minus 2x, but then there's also a half, because in disguise, it's really 1 minus x squared to the 1/2. So we've done this calculation enough times that I'm not going to carry it out completely. I want you to think about what it is. It turns out to be minus x up here because the half and the 2 cancel. And now the thing that we have to integrate is this arc length element, as it's called, ds, and that's going to be the square root of 1 plus y prime squared dx. And so I'm going to have to carry out the calculation, some messy calculation here, which is that this is 1 plus the quantity minus x over square root of 1 minus x squared squared. So I have to figure out what's under the square root sign over here in order to carry out this calculation. So let's do that. This is 1 plus x squared over 1 minus x squared. That's what this simplifies to. And then that's equal to, over a common denominator, 1 minus x squared, 1 minus x squared plus x squared. And there is a little bit of simplification now, because the two x squareds cancel, and we get 1 over 1 minus x squared. All right, so now I get to finish off the calculation by actually figuring out what the arc length is. And what is it? Well, this alpha is equal to the integral from 0 to a of ds. Well, it's going to be the square root of what I have here, right? So this was the square. This was just what was underneath the square root sign, right? This is 1 plus y prime squared. I have to take the square root of that. So what I get here is dx over the square root of 1 minus x squared. And now we recognize this. The antiderivative of this is something that we know. This is the inverse sign, evaluated at 0 and a, which is just giving us the inverse sign of a, because the inverse sign of 0 is equal to 0. All right, so alpha is equal to the inverse sign of a. Now that's a very fancy way of saying that sine alpha is equal to a. That's the equivalent statement here. And what's going on here is something that's just a little deeper than it looks, which is this. We've just figured out a geometric interpretation of what's going on here. That is, that we went a distance alpha along this arc. And now remember that the radius here is the radius is 1, right? And this horizontal distance here is a, right? This distance here is a.